This lesson is on the area of quadrilaterals and triangles. We're going to start by figuring out how to find the area of a parallelogram. Then we're going to talk about the definition of height of any polygon, how to find the area of trapezoids, the area of kites and also of rhombi, that's the plural of rhombus, and then finally the area of triangles. The area of quadrilaterals. So remember this diagram from our previous lesson that shows us this relationship between the special quadrilaterals. We're going to start with a rectangle, which we learned a long time ago what the area of a rectangle is. The area of a rectangle is base times height. It's also true for any kind of parallelogram, not just a rectangle. It's base times height. Now, to define the height of any polygon, the height of any polygon is perpendicular to the base. So to find the area of a triangle, of a rectangle, it's simply base times height, because it is a right angle in each of the corners, so it is perpendicular to the base. That line of 4 is perpendicular to the line of 6. And so I just call it base times height. Now I simply have to substitute in. My base is that bottom blue line there, so I'll substitute in a 6. And my height is that red line there, so I'll substitute in a 4. Multiply those out, and I get 24. So the area of this rectangle is 24. Next, let's talk about a polygon. The area of a polygon is also base times height. The base in this example is 6, so I can substitute 6 in. Now to find my height, I have to find the line that is perpendicular to the base. And I know that this line is perpendicular to the base because it forms a right angle, and that's the definition of perpendicular. So this line in red here is my height. So I can substitute in 3 as my height, multiply it out, and the area of this parallelogram is 18. Next, let's talk about trapezoids. The area of a trapezoid is the average of its bases. In the examples over here, that's the one on the top and the one on the bottom. The bases of a trapezoid are the one set of sides that are parallel to each other. And I take that and multiply by the height. So let's do an example of finding the area of a trapezoid. Here's a trapezoid. I'm going to take the average of the bases times the height. First, I have to find my bases, and again, those are the lines that are parallel, so those are in red. To find the average of any two numbers, I add them together and then divide by the number of things there are, in this case 2. So 7 plus 5 is 12, divided by 2 is 6. So the average of the bases here is 6. My height, I have to find the line that is perpendicular to the base. And this line right here is perpendicular to the base, and I know that because of the right angle symbol that's right there. So 2, this line right here, which I'll put in blue, is my height. So I can substitute in 2 for my height, and I get 6 times 2 is 12. So the area of this trapezoid is 12. Actually, you can think of it that the average of the bases times the height is a formula for trapezoids and for parallelograms, but it's just easier to just call parallelograms base times height, because in parallelograms my opposite sides are equal. So the average of two numbers that are equal is just that same number. So there's no reason to do that extra step. But I could think of it that the average of bases times the height will work for trapezoids and parallelograms, but it's just generally easier to think of it as base times height for parallelograms and the average of the bases times the height for trapezoids. The final type of quadrilateral we have to figure out the area for is a kite. And for a kite, I take 1/2 times the diameter of 1 times the diameter of 2. The diameter is the line going from one corner to the other. So in this case, there's one diameter from left to right and one going straight up and down from the top point to the bottom point. Multiply those together, divide by 2, and I have my area. That formula of 1/2 diameter 1 times diameter 2 also works for a rhombus, and since a square is a type of rhombus, it also works for a square. So to find the area of a square rhombus, I could either take the base times the height, but if I don't have those, I only have the diameters. I can take 1/2 diameter 1 times diameter 2. Now let's talk about the area of a triangle. Notice that if I can take any triangle, I can rotate it around the midpoint of a side to form a parallelogram. And it makes two triangles that are exactly the same. And therefore, each triangle has 1/2 of the area of a parallelogram. And a parallelogram, we just got through saying, is base times height. So a triangle is half of that, so the area of a triangle is 1/2 base times height. So here are some examples of how to find the area of a triangle. If I have a right triangle, right there is an example. I have to take 1/2 base times height, so my base is 7 there. And my height, which is perpendicular to the base, since it's a right triangle, that line right there, 4, is perpendicular to the base because it makes a right angle. So 4 is my height, so I can substitute that in. Multiply that together, and I have 1/2 of 28, and 1/2 of 28 is 14. So the area of this right triangle is 14. If I have just an acute triangle, there's an acute triangle. So again, my formula is 1/2 BH, or 1/2 base times height. My base in this example is 4, so I can substitute it in. My height in this example, because it is perpendicular to the base, that line right here is perpendicular to the base, and so my height is 2. I can substitute that in. 1/2 of 4 times 2, 4 times 2 is 8, so 1/2 of 8 is 4. So the area of this triangle is 4. Finally, an obtuse triangle. There's an example of an obtuse triangle. Now those lines that are dotted are not part of the triangle, but there's no way that I can draw the height of this triangle within the triangle because I have to go to the top point, and if I do a line that's perpendicular to the base, it'll be outside the triangle. And so by convention, we use these dotted lines to show us what the height is. Had we extended that base 7 out and drawn a line perpendicular to the top, that would be that line 10. And the formula is again the same. 1/2 BH, or 1/2 base times height. Substitute in my base of 7. Plug that in. And again, this 10 is perpendicular to the base. So I know that's the height. Substitute that in and have it in blue here. Substitute it in of 10. So now I just have to multiply it out. I have 1/2 of 70. And 1/2 of 70 is 35. So the area of this obtuse triangle is 35. Now sometimes you'll be asked to find the area of a shaded region made up of two shapes. What you need to do is find the area of each shape individually and then subtract as necessary. Let me give you an example. So this figure below here is a parallelogram, and it has a right triangle inside of it. And I want to find the area of the stuff in yellow that's shaded in yellow. So my first step is to find the area of a parallelogram, which we know is base times height. So in this example, my base is 20 and my height is 15. So I can substitute those in, and I get that the area of the entire parallelogram is 300. Next, I have to find the area of my triangle, which is 1/2 base times height. The base is 20 minus this piece that it isn't part of the base, which is 6. And the height is the same height as that of the parallelogram 15. So I have to multiply that out. I get 1/2 of 14 times 15. 14 times 15 is 210, and 1/2 of that is 105. So now I have the area of the whole parallelogram and the area of that triangle in white. So to find the area of the stuff in yellow, I have to subtract. So the area of the yellow is the area of the parallelogram minus the area of the triangle. So that's 300 minus 105, which is 195. So the area of the shaded region in yellow is 195.